Assalamu alaikum. Hassan Termus from Al Mahdi Schools. We will start now by Chapter 2 in our textbook, Numerical Warm-Up, and this is the Part 1 of this lesson. Objectives: factorize using identities and completing the square. Define and use the sets of numbers n, z, q, and r. Materials: we need draft papers, pens, calculator, textbook, and copybook. Let's start by factorization techniques. First, taking out a common factor. Example 1. Factorize a. We have an expression a. The common factor in this expression is 1 plus x or x plus 1. So we have three quantities and x plus 1 found in each of the following three quantities. So we take the factor x plus 1 is a solution and put it inside two parentheses, and then we open a big bracket and write the three remaining factors in each of the following quantities. Then we expand inside the big brackets, and finally we reduce inside the two big parentheses to find the factorized form of a. Example 2. Factorize b. Here the common factor is not clear, so first of all we take a common factor out of 15x minus 3. Then in step 2 we write plus instead of minus, and we reverse 1 minus 5x into 5x minus 1. Finally, we have a clear common factor here, 5x minus 1. We write it inside two parentheses and we open a big bracket, write the remaining factors, and expand, finally reduce to find the factorized form. But here we take 12, a common factor, inside the second factor to find the final factorized form of b. Application 1. Factorize each of the following expressions. Stop the video, take your time, try by yourself, and then check the solution. Solution. This is the part 1. Take a common factor and then expand, reduce to find the factorized form. This is part 2. Take a common factor, make it clear, and then expand between the big brackets and finally find the factorized form of b. Using remarkable identities. This is the second factorization technique. All of us know what are the remarkable identities, three formulas. Let's start by example 3. We have c x squared plus 2x plus 1. We write first, to factorize c, we write x squared. Then we write the final term 1 power 2, 1 square, and then check in the middle. In the middle we have 2 times x, the first term, times 1, the last term. So we have x plus 1 squared according to the identity a plus b squared equal a squared plus 2ab plus b squared. Example 4. Factorize d. We have d looks like the third remarkable identity. Here x plus 2 instead of a and y minus 5 instead of b. So we write directly according to the formula x plus 2 minus y minus 5 all into x plus 2 plus y minus 5, and then we expand and reduce to find the factorized form of d. Application 2. Factorize each of the following expressions. Stop the video and try by yourself. The solution. This is the solution of part 1. This is the solution of part 2. And this is the solution of part 3 according to difference of two squares. Let's start by using remarkable identities but new forms. We have 4 new forms of remarkable identities. Let's take an example. Factorize e. First of all, we write instead of 64, 4 power 3, and instead of 125, we write 5 power 3. Then we write 4x all cube plus 5y all cube. Then we write according to the expression a cube plus b cube the factorized form of this expression, and we get this factorized form of E. Example 6. Factorize f. First of all, f is made up of 4 terms, and we have a plus and minus signs, so we use the second identity. First of all, we write the first and the final term in the form of number to the power 3, then we write the intermediate terms, and finally, according to the formula, directly we can write 2 minus m all to the power 3. Application 3. Use your draft papers and try by yourself. Stop the video. Okay, this is the solution of part 1 and the solution of part 2, 4 terms, and this is the solution of part 3. We convert power 6 into power 3, then power 2, and use the identities, the convenient identities, to find the factorized form. Completing the square. It is a totally new technique in factorization. Example 7, g x squared minus 4x plus 3. The solution. None of the previous techniques can be used for factorizing g. Let us start by factorization step by step. First step, in our example, we take minus 4, the number multiplied by x, then we divide it by 2, and then we square minus 2 to get 4. This number is a convenient term that we will add and subtract it in step 2. Here's the step 2. We write x squared minus 4x, then we add 4 and subtract 4, then we write plus 3. The first 3 terms are the first group, the second last terms the second group. The first group we can write at x minus 2 all square according to the identity. Minus 4 plus 3 equals to minus 1. Then we can do difference of 2 squares, the remarkable identity here, to find x minus 3 into x minus 1. Example 8. Factorize h. First of all, we take 2 as a common factor in order to make the coefficient of x squared equals to 1. Then we add and subtract a convenient term, and finally we reduce inside the 2 parentheses and do the remarkable identity to get the factorized form. Here we expand 2 into x minus 3 over 2 to get a simpler form of the factorized form. Application 4. Factorize a. Stop the video and try by yourself. And this is the solution, taking 2 common factor and then completing the square by add and subtract to find finally the factorized form. Sets of numbers. Natural numbers. The set of natural numbers are designated by n, where n equals to 0, 1, 2, 3, 4 and so on till plus infinity. Remark, the set n without 0 is denoted by n star. Integers. Natural numbers and their opposites form the set of integers, z. So we write 0 plus 1 plus 2 plus 3 plus 4 and so on, and minus 1 minus 2 minus 3 minus 4 and so on. This is the set z. The set z without 0 is denoted by z star. The set of negative integers denoted by z minus. The set of positive integers denoted by z plus. Notice that z plus, the positive integers, equals to n, the natural numbers. So z plus subset in z. So n subset in z. Rational numbers. The set of rational numbers are designated by q. Any rational number can be written as a fraction where the numerator and denominator are integers. The set q without 0 is denoted by q star. The set of negative rational numbers denoted by q minus. The set of positive rational numbers denoted by q plus. Notice that all the integers belongs to set z. Also they are belong to set q, so z subset in q. Irrational numbers are the numbers that cannot be written in the form of a over b. So we cannot write the irrational numbers in a form of a fraction where a and b are two integers. Example: radical 2, radical 3, radical 5, radical 7, pi. All of these numbers are irrationals, since we cannot write radical 2 or radical 3 or any of these numbers in a form of a fraction. So finally, what are the real numbers? Rational numbers and irrational numbers form the set, which is called the set of real numbers and is denoted by R. Remark: natural numbers, the set of natural numbers, and subset in the set of integers, Z, subset in the set of rational numbers, Q, subset in the set of real numbers, R. This is your assignment, and this is the summary of the part 1 of the lesson, summary of the part 2, and we have two objectives next. And thank you. Wassalamu alaikum.